Okay, in this video I'm going to solve another example of how to integrate using integration by parts, but this time we're going to use it twice. Let's cross the bridge when we come to it. So what we've got here is integral of x squared sine x dx. Well, again, we pick our u and dv, so I'll pretend that this is dv and x squared dx is my u, sorry. And by the way, it's not always like the first one is u and the second one dv, because I could have just simply written it as sine x squared, so don't be fooled. So u is going to be x squared, and if we take derivative of that, du, that would give us 2x. Again, our dv is going to be sine x. So if we take the integral of that, that would be minus that would be minus cosine x. So let's just rewrite it down as the integration by parts formula. So we've got uv, so u here is x squared and v is minus cosine x, but I'm going to put the minus next to the x squared. It just looks better, looks neater. So minus x squared minus cosine x, and then minus the integral of v du. Again, it's gonna be minus cosine x, but I'll pull the minus out, so that's gonna be plus. And the 2x, I'm gonna pull the 2 out because it's a constant, so we'll end up with x only and cosine x dx. But this time, well, we can't actually integrate that. I'm gonna have to use integration by parts again to be able to come to the final answer. But we can see that we've made progress, because, well, x squared sine x looks harder. It just looks more complicated than this version of it. So because we got x to the power 2, but here only x to the power 1, so to the first power. So you can see that we made progress. But now what I'm going to do now is integrate this bit by parts. So I'm going to forget about this bit for a while now. Let's just do integration by parts for this bit only. Again, we choose our u, which is going to be x, so du is going to be 1 dx. It's okay if you want to put dx or not, doesn't matter. And dv is going to be our cosine x, and v would be, sorry, running out of space, v would be if we integrate that, we're going to come with sine x. Now I'm going to plot in the integration formula again, uv. So our u here is x, and our v is sine x, right? Minus integration of v du. Well, our v here is sine x, and du is 1, so I'm just going to put sine x dx. Right? Now, that's actually easy because we only got sine x, so we can integrate that, definitely. So if we want to integrate that, leave this bar a bit, minus, if we want to integrate that, we just get, we're going to get minus cosine x, but I'm going to put the minus out and make this positive as we did last time, so end up with cosine x plus c. And that's not the final answer, nope, that's only the integration of this bit. Now I'm just going to include this bit. I'm going to plot in this bit with this. So let me just zoom out. No, I don't have to zoom out. So it's going to be minus x squared cosine x plus 2, then times this, right? So let me just do in a plain paper. Again, what I'm doing is just rearranging this, simplifying it. Plus, well, 2 is multiply this, so we can just distribute 2 inside the bracket. So it's going to be 2 times cosine x sine x is going to be 2x sine x, then times cosine is going to be plus 2 cosine x, and don't forget OSC. So yeah, that's our final answer. That's our final integral of this. I know it's a little bit hectic, so if you don't know about integration by parts, you probably don't want to watch this video, because there are a lot of, I've made another video, a previous video, which is integration by parts for like the very basic example. So this one only if you watch this video only if you are familiar with integration by parts. It's just for more complicated examples. So yeah, that's it. It's a bit hectic, but that's the final answer for x squared times sine x dx. That's the final answer.